What is up, everybody? Sysadmin Sean here, and today we're going to be talking about the Linux Upskill Challenge Day 19, which is inodes, symlinks, and other shortcuts. This is kind of new information to me. I didn't know a whole lot of the actual details related to this. I just sort of understood it worked. So I'm going to go a little bit slower on this one and kind of really read it out and show it off. And again, this one is pretty much the exact same as it would look in Red Hat as Ubuntu, so we're not going to be changing anything here. Basically, today's topic gives a peek under the covers at the technical detail of how files are stored. Linux supports a large number of different file systems, and that's true. Although on a server, you'll typically be dealing with ext3, ext4, or perhaps btrfs. I've also used xfs before, so that one's around as well. But today we won't be dealing with any of those. Instead, we'll be dealing with the layer of Linux that sits above all of these, the Linux Virtual File System, or VFS. VFS is a key part of Linux, and an overview of it and some of its surrounding concepts is very useful in confidently administering a system. Obviously, I've been pretty confident at administering systems without knowing this part. Linux has an extra layer between the file name and the file's actual data on the disk. This is the inode. This has a numerical value, which you can see most easily in two ways. So let's see if we do ls-li etc hosts. So there's that value right there. That's the inode value for etc hosts on this system. And if we use stat on the same file, it'll give us information as well. So we can see here's the inode. Here's how many blocks it is. Here's its size, the IO blocks. It's a regular file. Access information. Stat is a really handy command if you want to get a whole bunch of information really quick about a single file. Super awesome. Every file name points to an inode, which in turn points to the actual data on the disk. This means that several file names could point to the same inode and hence have exactly the same contents. In fact, this is a standard technique called a hard link. The other important thing to note is that when we view the permissions, ownership, and dates of file names, these attributes are actually kept at the inode level, not the file name. Much of the time, this distinction is just theoretical, but it can be very important. Two sorts of links. So this is something I had no idea about. I knew about soft links. I'd never heard of hard links before. So this is good info. So let's go to the home directory again, which we're in. And then let's make a hard link to etc password, ln etc password, and we'll call it link 1. And then we'll also make a symbolic link, ln-s for symbolic, etc password, link 2. Now let's check those out. So link 1, as you can see, has 2230634 as its inode, and link 2 has a new inode of 3031520. So note that the permissions, right, we have full access here on this soft link because we have full access to this. This one, the hard link, is referencing the permissions on the actual file. And if we go to etc password, so if we do ls li etc password, oh, gotta do dash, we will see that link 1 and its inode match the actual inode of etc password, as does its permissions, rwrr. The soft link, again, is a file that exists, as a link to the original file. So this one's permissions are going to show up different because it's really the permissions on the link, whereas link 1 is basically a hard link. It is the exact same file as etc password, so its permissions are going to be the same, and its inode is going to be the same. That's pretty cool. I did not know that about hard links. Note that the permissions on the symlink generally show as allowing everything, but what matters is the permission on the file it points to. Symbolic links I use a lot for, I actually use paths. So if I did, like, let's see. Oh, we can do this. ln-s var log logs. So now we have in our folder here a directory called logs. If I go into logs, where am I? I'm in root logs. And inside that, there is a folder called log, a symlink that goes to var log. What we do cd log. It says we're in root logs, but if we look in here, this is clearly var log. That's how I use symlinks. But anyway, We really didn't need to do that. I think logs and root probably. Yeah, links to quite a few logs anyway. Both hard and symlinks are widely used in Linux, but symlinks are especially common. Symlinks, soft links, for example, ls-ltr etc rcd2. So let's take a look at that. ls-ltr etc rc2.d. So as you can see, these are all symbolic links. So this one goes to init dbus, this one goes to init Plymouth, init d unattended, init d console setup. All of these are, and as you can see, they're marked as symbolic links. It's also very common to have something like program, program-v3, program-v4, where program is a symbolic link originally to v3, but now it points to v4 and could be pointed back if required. So that one, I wish I could show that one without having to do a bunch of work real quick. I didn't even think about it. I have Java on here. Let's see. No. Locate Java. There is some Java. User share Java. See if they have it in here. Java is one off the top of my head that does this a lot. So you can see right here, this is a good example. So we have lib intl-0.21.jar, and this baseline file that would get called, this soft link, points to this version. Now, if we updated it, this file might stay around, and then there might be a 0.22, and then this link would get updated to point to 0.22 instead of 0.21. And if something broke in the update or something, you could change the link to point back to the old version should you need to. That's another way that symbolic links are used a lot in Linux systems. And Java is just one that came to my head because we used to do symbolic links for like Java latest, Java previous, so that our developers and stuff would know which ones to reference depending on which version of Java they wanted to work with. So here are the differences between hard links and symbolic soft links. Hard links only link to a file, not a directory. They can't reference a file on a different disk or volume. Links will reference a file even if it's moved, so that's important to note. Links reference inode/physical locations on the disk. Symbolic links can link to directories, which is how I use them a lot. They can reference a file or folder on a different hard disk or volume. That's really how I use it a lot. So for instance, in my HPC environments, I have user accounts, and when they log in, they go to their home directory, home/user ID, right? Well, they also have some specialty folders on the system just for them to put data. So there's a /data partition on a whole nother set of drives. And there's also a /scratch drive where they can put scratch files for writing stuff out to a disk before finishing larger computations. I have a script that I've made that when they log in the first time, it checks to see if those symbolic links and those paths exist. And if they don't, it creates it for the user and then builds those links. So they don't have to know, oh, I need to go to /data/my username. They can just type cd data inside their home directory and it takes them directly to that drive. Really handy for the users. And it lets them access things via like WinSCP or MoXterm, where they can just double click the directory and then copy files down when they need to. All right. Symbolic links remain if the original file is deleted, and those will show up as, let's see, like this. You see how this is gone? So these are red links. They're not working anymore. They will show up like that. Links will not reference the file anymore if it is moved. So yeah, if this file had moved, this would go red like it's not there. Links reference abstract file names and directories, not physical locations, and they have their own inode like we showed. And that's about it for inodes and symbolic links and other shortcuts. That's how we do it in the Linux world. Not too difficult. I highly recommend you read the resources and kind of really focus on symbolic links. I feel like those get used a lot more, at least in my job role as a sysadmin, than most any other job roles. So maybe hard links are important in other environments and in other ways to do things. I just haven't ever really worked with hard links before, but now you know, and that's it. And we'll see you in the next one.